there, and welcome to The Explainer. Today we're going to break down one of those GED Science questions that, looks way more complicated than it really is. So let's just dive right in and build a strategy you can use to absolutely ace this test.
So, you ever look at a big block of text, a chart full of numbers, and a bunch of answer choices and just feel your brain freeze? Yeah, you're definitely not alone. These things are kind of designed to look intimidating, but here's a little secret. They all have a hidden structure.
And that's exactly what we're going to do right now. We're going to walk through a really common type of question, and I'm going to give you a super clear, step-by-step strategy you can use every single time. The goal is for you to walk into that test feeling ready and confident.
Okay, so the very first step in solving any of these things is to actually ignore the questions for a second. Seriously, before we do anything else, we have to crack the code of the experiment itself. We just need to figure out what is actually going on here. So this is our setup. We've got a biology class, a water plant, and a lamp. The trick is to ask two really simple questions. 1. What are they changing on purpose? That's the distance of the lamp. 2. What are they measuring to see what happens? The number of oxygen bubbles. And just like that, you found the cause and the effect.
So this becomes our little method for any experiment. First, what's the goal? They want to see how light affects the plant. Easy. Second, what are the variables? We just found them. They're changing the light distance and measuring oxygen bubbles. And third, this one's important, what's the key? What do those bubbles actually mean? Well, the passage tells us it's all about the rate of photosynthesis.
And here's the science behind it all. Photosynthesis. It's just the fancy word for how plants eat. They take in light, water, and carbon dioxide, and then make food for themselves and then release oxygen. So when we see those bubbles in the experiment, we're literally watching the plant breathe out oxygen. So more bubbles means more photosynthesis is happening. That is the key to this whole thing.
All right, now that we totally get the setup, we are ready to look at the first question. This kind of question is great because it's all about the data. The answer is literally just sitting there on the table waiting for us to find it.
Now let's just look for the pattern here. It's a story told in 2 columns. Look at the first column. The distance of the lamp goes up, right? 10, 20, 30, 40. Now look at what happens in the second column. The number of bubbles goes down. 48, 37, 24, 11. That relationship, as one thing goes up, the other goes down, is everything we need to know. So, here's our question. Which of these statements does our pattern support? Now we're going to use my favorite technique, elimination. Instead of just searching for the right answer, let's prove why the other 3 are impossible.
Let's just knock them down. Answer A says the fastest rate is at 40 centimeters. We look at the data, that's where we see the fewest bubbles, so that's the slowest rate. Wrong. Answer B says it stopped at 20 centimeters. Data says 37 bubbles. It's definitely still going. Wrong. And D says there's no effect? The number of bubbles changes at every single distance, so there's clearly an effect. Wrong again. And that just leaves us with C. Let's check it. Does increasing light intensity, which means moving the lamp closer, increase the rate? Well, the closest distance is 10 centimeters, and that's where we have 48 bubbles, the highest number. It perfectly matches the pattern we saw in the data. See? Let the data do the talking. Awesome. Okay, now we're going to level up with a slightly different kind of question. This next one isn't just about reading a chart. It's about using a little bit of that core science knowledge we talked about. Okay, so check this out. They're changing one of the ingredients. The first time, they used a solution with plenty of carbon dioxide, or CO2. Now they're switching to plain water with less CO2. So the big question is, how does taking away an ingredient change things?
Remember that photosynthesis idea from before? Well, here it is in its official formula. Now don't let all the letters and numbers freak you out. Just think of it like a recipe. The stuff on the left of the arrow, those are your ingredients. And look what's right there near the beginning. CO2. Carbon dioxide is an absolutely essential ingredient. You can't do photosynthesis without it. Think of it this way. Say you're baking a cake. The recipe calls for 2 cups of flour, but you only have 1 cup. What happens? You're going to end up with a much smaller cake, right? Or maybe a flat one.
It's the exact same idea in chemistry. If you have less of a key ingredient, you're going to get less of the final product.
So the only possible answer here is C. If the plant has less CO2 to work with, it just can't perform as much photosynthesis, and that means fewer oxygen bubbles. And this isn't just going to happen at one distance. It's going to limit the whole reaction no matter how close or far the light is.
Okay, let's put this all together. What we just did, it wasn't just about solving two little problems. We've actually built a playbook, a powerful set of strategies that you can use on pretty much any experiment-based question that the GED Science test throws at you.
And here it is, your winning playbook. Just 4 simple steps. 1. Crack the code. Figure out the goal and the variables first. 2. Let the data guide you. Find the pattern in the chart. 3. Use what you know. Apply that key science concept. And 4. Eliminate to win. Prove the other answers wrong so you can be 100% confident in the right one. This is your game plan.
You have the tools. You've got the strategy. These questions aren't a big, scary mystery anymore. They're just puzzles, and you now know exactly how to solve them. You've got this.